Hey Techno Studs, time to take a deeper dive into Ethernet cables. Let's take a look at Ethernet cables. All right, in this video, what we're going to cover is the different categories of twisted pair that are out there that we can use for these Ethernet cables. We're going to talk about pairs and make sure we have a deep understanding of how these pairs are set up. We're going to talk about termination standards and RJ45 connectors, so we can take a look at what those look like and how that plays into cable types, such as straight through cables or crossover cables. So let's get started. Throughout this information technology era, we've had to increase the amount of data that goes through our systems. And with that, physically, we've had to find better ways to transmit this data. And that's what these categories are all about. We have different categories of cables that we use that have improved over time. So we started out with category 3, or what we call Cat 3 cable. And that Cat 3 cable had a much lower frequency capability than the cables nowadays, and only could support certain speeds across it. So as we progressed, we found better ways to improve the speed, the frequency and speed of these different cables, getting faster and faster connections. So that's where you see Cat 3, Cat 5, Cat 5E, Cat 6, Cat 7, Cat 7A, Cat 8. There's actually a lot of categories in between these. I've just picked out some of the big ones here. So we continue to improve. One of the big improvements with all of these, there are adjustments that we've made in how we separate these out and limit how much EMI comes in, limit how much crosstalk. But one of the big differences with all of these different categories is how many twists there are in the cable. What we found is in the Cat 3, we've just loosely twisted the cables, and we found that there was a lot more crosstalk, and the more we twisted, the less between those pairs, with a pair, the more we twisted it, the less crosstalk there was. So Cat 5 has a lot more twist to it, and so on and so forth. So although know that there are other differences between these cables, the biggest one is how many twists per inch that we have with these cables. All right, let's talk about pairs. Here we have 8 conductors. If I were to circle all of these lines here, these are the 8 different conductors we have for data. So we call each of those that are linked together and of a similar color there is a pair. So we've got the orange pair, we got the green pair, we got the blue and the brown. So we've got 8 conductors and 4 pairs. Right? Within each one of those, there is the conductor, and then there is the insulator that protects it. The pair is twisted together, and that twist allows to minimize the crosstalk between these different lines and other cables that are running next to it. So we've got this twist along it. So the blue pair is what we consider pair number 1. The green, or the orange pair is pair 2, the green pair is 3, and then the brown pair is 4. So these are the different pairs. Now, in a lot of our Ethernet standards, we only actually use 2 of the pairs. And so the 2 pairs that we typically use are pairs 2 and 3. And that's because some of our jacks will still use pair 1 for phone systems. We'll talk a little more about that when we get into the next slide. But typically a lot of our standards, not all of our standards, but a lot of our standards use pairs 2 and 3. So typically we're not taking these wires and wiring the equipment directly. Most of the time we're plugging in this equipment with some sort of connector on the end. And more common than not, that connector is an RJ45 connector. So let's take a look at RJ45 connectors. RJ, once again, stands for registered jack, and 45. So and there's different ones out there. So there's RJ11 is another really common one. But mostly when we're talking about data, we're talking about RJ45 connectors. And so we see this plastic housing here, and this right here is usually the clip. So we don't want, when we plug this in, we don't want that jack to come back out. And so there's a click that happens, a clip that will click into place that happens. And then to get that back out, we have to depress that clip and pull it back out. So that is what's being represented by this area right here. And then each one of these are the conductors. And so when this slides into a piece of equipment, then those conductors make contact with conductors of the network interface card, and therefore we complete this circuit, complete the whole circuit. So these are the RJ45 connectors. And what we do is we have to line up the data lines on each side so that way this communication can happen between these two devices. They have to know which pairs they're communicating on. And so that's where we have a couple different standards that the T568A and T568B are different pinouts for these RJ45 connectors. So T568A and T568B are those different connection standards. What it essentially tells us is what should be pin 1, what should be pin 2, what should be pin 3. So on our jack, we actually have pins on here, and there's a total of 8 pins, so 6, 7, 8, and it's the same for each one of these. 3, 4, 5, 6, 7, 8. And we have to associate that with the different cables, the different conductors on the cables. So they're associated with these right here. So 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. So then we have, we can see that really these are mostly the same, except for the blue is in the same place on both of these different termination standards. The brown is in the same place on these different termination standards. What we see the difference is, though, is the green and the orange is swapped. So the green takes pin 1 and 2 on this one versus it takes pin 3 and 6 on this one. And the orange 1 and 2 on the T568B is pins 3 and 6 on the T568A. So those two swap on these different connectors. So we're going to talk more about the termination standards, but just realize that we've got those two swapped on these two different termination standards. I want to make a couple observations of this connection just to point out some fast ways to recognize these connections. So first of all, we can see that it alternates between the solid color and the striped color. So we see a striped and then solid, stripe, solid, stripe, solid, stripe, solid. So it alternates between those. But what else is interesting about this is that we see that all of the colors are essentially paired up together. So the greens are together, the blues are together, the browns are together, and the oranges are together. So they're together with the exception of pin 3 and 6, which are separated out. And so I just want to explain a little bit about the background of why that's the case. So one thing that has happened in the past is that we've used some of these same connections for phone systems. And the phone systems just need 2 pair traditionally to operate. A phone just needs two conductors, 1 pair to operate. And so that typically was this pair 1 right here, the first pair, which was the blue cables, the white, blue, and blue. So that is pin 1. And so those took the first place. And then what they did was they lined up the rest of the pairs. Pair 2 came next, and then pair 3 needed to be split. So you see pair 3 is split here, and then pair 4 is on the end. And so it's a little different. And sometimes if a phone had 2 lines, what it would use the center 2 and then the two outside from that. So that's another reason for this. So it kind of stemmed from the phone systems and the way the phone systems are set up. And in fact, if you look at an RJ11, which are used for phones, the RJ11 looks very similar to the RJ45, except for it's just a little bit smaller, and that's because it only uses 6 conductors. RJ11 is 6 conductors. And you can actually still use all of your Ethernet lines from your patch cables out and stuff, and you can plug in RJ11s into them. So you can use this either for data or for phone. And so that is one of the reasons why the odd space right here in the middle of these. But other than that, you can see, you can pick out how there are some similarities with these. All right, I'm going to jump into a few different cable types and why we would choose certain cable types and why we would use certain connection standards on each of the ends. So let's talk about that. So I've got 2 devices I'm connecting together. On this side, a computer, and this side, a switch. These each have a pinout that's a little different. So these pinouts, I'm going to label all of the conductors on this side if I were to look at that network interface card. And then same thing over here. This is the pinouts over here, 5, 6, 7, 8 for each of the conductors. If you notice that pins on a computer, pins 1 and 2 are the transmits, versus on the switch, pins 1 and 2 are the receive. Pins 3 and 6 on the computer are the receive, and pins 3 and 6 on the switch are the transmits. This is intentionally so that when we connect a cable between these two, then what's happening is the transmits are sending data to the receives of this equipment. And vice versa, the switch now is transmitting to the receives of this computer. And everything lines up. This is what we call a straight through cable. So we want a straight through cable when we're connecting a computer to a switch. Now, where does that come into? We talked a little bit about our different pinouts that we have and our T568A and T568B. Which one do we use? Well, in this case, it really doesn't matter as long as we use both on the same side. So if I put a T568A on this side, I would want a T568A on that side. If this was a T568B on that side, then I'm going to want a T568B on that side. So it really doesn't matter what those pins are on each side because the transmits are going to line up with the receives. So that is the straight through cable, is when your standard that you use is going to be the same on each side, and that is a straight through cable. So when is it different? When do we use what's called a crossover cable? Here in this example, I'm connecting a computer to a computer. In this case, if I had a straight through cable, it would be from the transmits would be connected together. So in other words, they're both trying to talk, but no one's listening. And then the receives are connected together. So now they're both listening on this line, but no one's talking. Obviously, communication is not going to happen. So what we need to do is we need a crossover cable. We need the transmits to come down and hit the receives on this side, and the receives to hit the transmits for communication to happen. And then the rest of these cables, because a lot of these cables, they don't, there's not the, we don't only use 2 pairs. So the rest of these, we are fine if we go straight through or not. So we just cross that over. So a crossover cable is when we have a T568A on one side and a B on the other, and the transmits and receives are flipped around. So now these 2 devices are similar, can talk to each other. So that's where you use a crossover cable. Now I'm going to cover a rollover cable, even though it's really not an Ethernet standard. I've not seen an Ethernet cable as a rollover cable. I have seen RJ45 ends, and I've seen twisted pair that are set up this way, but it's not really an Ethernet cable. A rollover cable is kind of similar, I guess, to a crossover cable, except for pin 1 goes to pin 8. Pin 2 goes to 7, 3, 6, 4, 5, 5, 4, 6, 3, 7, 2, and 8, 1. So essentially all those pins just get rolled over. And then the pinouts of those two different devices on each side just need to make sure that it can accept whatever transmit and receive. So I've got an example of a computer and a switch here, but once again, it's not really Ethernet that connects these two. But what would be in this case right here is if I'm consoled into a device, then sometimes I'll use this crossover cable to communicate from one device to another via that console cable. All right, so what we talked about is we started by talking about categories and the different categories of cable, although we typically don't say category 3, category 5. We say cat 3, cat 5. So that's the industry standards, is just to call it cat. Then we talked about the pairs and how the pairs are inside those twisted pairs, what they look like. And we talked about termination standards and those RJ45 connectors and how to put how those connectors are pinned out on each side. And we wrapped up with the different cable types being the crossover, the straight through, and the rollover cable. So thanks for joining me. Hope these videos are helping you out. If they are, can you help me out by hitting that like button?